Looking at 604 today, which is our short methods of differentiation. So last lesson, we looked at differentiation by first principles, which is quite a long and complex way to differentiate a function. And in 604, we're introduced to the short method, which is essentially like the really quick and really easy way to do that. So what we're provided with is a bunch of different rules. I'm not going to touch on these too much because that will become pretty self-explanatory as I work through the examples. But essentially, what we're looking at and how we would understand these rules is that this is saying the derivative in respect to x of this being our function equals this. So essentially, if I had, let's say, x squared, the 2 is my n value. So what I do is I bring my power to the front, and then I decrease the power by 1. So the differentiate or the derivative of x squared would be, so I bring the 2 down the front, it becomes 2x, and then I take 1 from the power. So 2 take 1 would just give me 1, or we would know that just to be 2x. And down here, an example in this one here is if we have a number in front of our x squared. So let's say we had 2x squared. Same rule applies, right? So we bring the power down and we multiply, and then we decrease the power by 1. So derivative of this, I'll bring the 2 down. It actually becomes 2 times the 2 that I had existing, 2x, and 2 take 1, which therefore would give me 4 out the front of x, and 2 take 1 for the power is just the power of 1, which is just 4x. Cool, so pretty basic stuff, and it's quite easy to get the hang of. So let's have a look at how it works in a couple of questions. So part A, we're asked to find the derivative of, so now's a good time to work on your notation. So let's use the y dash notation. So y equals 3x to the 8. So same, following the rule, I bring the power down the front and multiply, and then I take 1 from the power. So I'll essentially get 3 times 8 out the front of x to the 8 take 1, which 3 times 8 gives me 24. X to the 7 would be my answer there. That's a 7. Part B, differentiate. Now we're given another, over here I should have added y equals that, therefore this is y dash. The derivative is always represented with a dash if we're using y, or using this notation as well. So f of x in this case equals 7x cubed. Therefore, when we're deriving that function, f dash x is the notation we use. Same thing, bring the 3 down the front, so 3 times 7x to the 3 and take 1 from the power. So we're given 21x squared. So yeah, some pretty easy stuff considering in the last exercise we had to go through probably almost a page of working to get the answer. Now we can literally work towards just doing it in our heads, essentially. So let's move on. So the derivative of a sum of functions. So if there are several terms in an expression, we differentiate each one separately. That just means that if you had a function, let's say our function or our f of x equals, let's say, 2x cubed plus 6x squared, it's just saying do each term on its own. So what I'm going to differentiate first is the first term. So therefore, f dash x equals, remember, bring the 3 down the front and take 1 from the power. So 3 times 2x to the 3 take 1. And then, so that's my first term. And then I simply just add on my second term. And I'm going to add that onto the end of my derivative function. So 6x, the derivative, bring the 2 down the front. So we've got 2 times 6x to the 2 take 1. And we keep the same addition, subtraction in the middle. So I can just simplify this now. 3 times 2 is 6x squared plus 12 x to the 1, or just 12x. We don't have to put the 1 there. Anything to the power of 1 is just itself. And that's how I would derive a function with multiple terms, essentially. So let's have a look at, I think there's a couple of examples here. Well, there's a fair few examples here. So first I'm asked to differentiate x cubed plus x to the 4. So let's set A over here. Let's set y equal to x cubed plus x to the 4, which means our derivative function, or y dash, equals 3x to the power of 3 take 1, which is 2, plus bring the 4 down the front, 4x to the power of 4 take 1, which is 3. So that's my differentiate, or that's the function differentiated, or my derivative function, as they say. Part B, find the derivative of 7x. Well, 7x, x is technically to the power of 1, is it not? So again, follow the process. Bring the 1 down the front and take 1 from the power. So 1 times 7 just gives 7x. Now 1 take 1 gives me 0 as my power. Anything to the power of 0 we know is 1. So this is the same as 7 times 1, which just gives me 7. Perfect. Okay, part C. I'm given a function equals x to the 4 take x to the 3 plus 5. We didn't touch on this either when we just have a single number. So therefore my derivative function f dash of x, I can do the first 2 terms pretty easy now that I know what I'm doing, minus 3x to the 2. And if you ever are given a single number, when we derive a single number, if there is no x value, it just essentially deletes itself. So unless there's an x afterwards, we just have a constant like a 5 or a plus 10 or a minus 8, it just deletes itself because the derivative just vanishes. So that would be our derivative function there. We don't have to do anything with the last term because it's just a constant. It gets deleted when we derive. Okay, part D, let's have a look at D. So D, differentiate or find the derivative of y equals 4x to the 7. That's pretty easy again. Bring the power down the front. So that equals 7 times 4x to the 7 minus 1, which is 6. So 7 times 4 is 28, x to the 6. Perfect. Part E here. So we're given a function that's asking us to evaluate the derivative function when x equals -1. So this is going to be a 2-step question. So first of all, we need to find the derivative function, and then we need to sub -1 into that function. So first, let's find the derivative function. So I'm given f of x there, so I'm not going to write it again. I'm just going to go straight to the derivative function. F dash of x equals, pretty simple here, 5 down the front. 5 times 2 makes 10, x to the 4 minus 7 times 3 is 21, x squared plus 5. That's my derivative function. Remember that my constants just get deleted. Now I'm asked to evaluate f dash of x, which I've found, when x equals -1. So f dash of -1, everywhere x is, I sub in my -1 value. -1 to the 4th minus 21, -1 squared plus 5. So all that I need to take into account here is my signs. So when I've got an even power, my negative cancels. So it's 10 times 1, which just gives 10. Again, here I've got an even power, so this negative becomes a positive. So I'm taking away 21 times 1, which is take away 21 or -21 plus 5. So 10 plus 5 gives 15. 15 take 21 gives -6. So -6 would be my answer for part E. Okay, part F. So essentially here we're given two terms, and we're going to derive these. Just give me a second. Using one of my rules that I was provided with earlier. Okay, let's move up. Surely there has to be an easy way to do this. There we go. Okay, part F. So if I scroll up back to one of my my laws up here. Okay, so